Alright, I'm going to get back into this three-eye atlas and why I believe it is a white dwarf. I can't say it right now. Dwarf. Alright, anyways, I'm going to get into it. Alright, here we go. No, a typical white dwarf is not significantly smaller than the sun. It is smaller. Look, this is a white dwarf. This is the sun. Compared to the size of the Earth, though they are incredibly dense, packing a rough mass of the sun, half of it into a smaller volume. Therefore, a white dwarf is smaller than the sun, but can be similar in mass and slightly more massive. Alright, now this thing is heading past Mars, and I'm telling you, it's going to cause some planets to get off of alignment. Here's some more information. So this thing's been producing carbon, and it has a lot of nickel. So here we go. No, they don't produce carbon dioxide, but they do, and I'm gonna show you. White dwarfs have no nuclear fusion to burn, no capacity to fuse elements to generate energy. The immense pressure of the temperature inside a white dwarf do not support chemical reactions that would create carbon dioxide. Now this three-eye atlas is producing a lot of carbon dioxide. How nickel is produced and why it's linked to a white dwarf when you just told me that it's not. Nickel is not a product of a white dwarf's normal life, but it's formed when a white dwarf is involved in a type of supernova explosion. Now, I said this could have been explosion, this could have been piece of a star that was hurtled out into space, moving at 136,000 miles an hour. It's going to be faster when it goes past the sun. These explosions occur when a white dwarf accelerates enough mass from a companion star or collides with another white dwarf to exceed a critical mass limit, the Kanderschker limit, leading to a thermonuclear detonation. This explosive event is a major site for producing elements like nickel, iron, in the manganese of the universe. I'm telling you, this thing is a white dwarf hurtling through space. It's got a ton of gravity, and it's producing carbon, and it's more nickel than iron. It is not a frickin' UFO. A white dwarf type of supernova is a binary system, can sift material from its companion star, increasing its mass. If it reaches a critical mass known as the Chandrasekhar limit, about 1.4 solar masses, it triggers a runaway thermonuclear explosion called a type La supernova. If a white dwarf survives this critical explosion, the immense energy from the blast can propel it away at hundreds of thousands of miles or kilometers per second. I'm telling you, I am on to something. I got more facts. Joe Rogan, you really need to put me on your TV program. Yes, a white dwarf can be thrown into space, especially from a companion star's supernova explosion, known as a hypervelocity white dwarfs. These stellar remnants move so fast that they can be ejected from the star cluster and even our own galaxy. How a runaway dwarf can be created. There are several scenarios in which a white dwarf can be spotted across space, extreme speeds, moving a catastrophic event within the binary system. I'm telling you, this three-eye atlas is a white dwarf. I'm the only one coming up with this, and of course my videos don't get no views Because, you know, they want to go off with, like, it's extraterrestrials, it's aliens, they're coming to Earth. No, they're not. When they're going as close to Earth as possible, we're going to be on the backside of the sun. Now, they may stop over at Mars and colonize Mars. It may, but it's not aliens. It may take Mars and top it off this planetary lineup around the sun, kick it out into space. It might even draw Mars to collide with it. I'm telling you, this 3-eye atlas is a white dwarf star. I know what I'm talking about. I have been studying space, stars, and galaxies ever since I was a little kid. And I've been telling you all for the last 40 years that space has no boundaries. It is going to keep going. The farther you zoom, the farther you're going to see. And space is not 13.5 billion years old. And the Big Bang was not the Big Bang creating the whole universe. The Big Bang was the sun exploding and creating these stars, the star, and the planets that revolve around it inside the galaxy. The galaxy was not created from the Big Bang of Earth. It was created when the sun exploded 13 billion years ago and then created these planets. And I know you're like, oh, Earth's only 4 million years old. No, it's not. You got to realize it spent a couple billion years floating around in space, collecting matter, creating a gravity, then being collided by more meteors and asteroids. When that happens, everything melts, refreezes, rehardens, and then the clock resets. So you can't tell me how old anything is, because I'm telling you, you're wrong.